All right, to start the class, I have put up a warm-up on the board. 6 problems against simple powers of 3. Please take a few minutes to evaluate those, and we'll go over them once you guys are done. And after that, we'll start the section on roots and radical expressions, which is section 7.1 in your book. All right, you guys ready to go over these? Let's start. What's 3 to the first power? 3, very good. What's 3 to the second power?
9.
Yeah, chop down 9. 3 to the third power is 27. 3 to the fourth power? 81. Excellent. 3 to the fifth is 243. And 3 to the sixth? 729. Now, and we had a problem evaluating these powers. I hope not. You guys have been working on similar problems. Now, today we're going to introduce the concept of a root. Now, if I'm talking about powers, can somebody tell me what is a root? You should know the kind of the general idea of what a root is. Somebody? Again, let's say I told you that 3 to the 6th power is 729. How do we write that out in a word form as a root expression? Yes, please.
Like 3 times 3
Okay, that's how we actually write out this expression. That's good. It's 3 times 3 times 3 times 3 times 3 times 3. Now, if I want to go the opposite way, go from 729 to 3. Again, what operation do we use? Yes?
The square root?
Okay, the square root. Now, square root is going to be used for which power? Square means
No.
second power, right? But very good. You guys have learned about square roots before, so let's take a look at it again. Over here, 3 squared equals to 9. So how would you say in your own words to use the square root to reverse this expression?
The square root of 9 is equal to 3.
Very good. The square root of 9 is equal to 3. Square root of 9 is 3. Now, we use a square root for the square root of a number. Again, 3 squared is 9, therefore the square root of 9 is 3. Can somebody take a guess, venture a guess? What are we going to call the roots that correspond to powers that are higher than 2? Yes?
Radical.
Okay, radical is a root. However, again, we had a square root, which corresponds to the power of 2. For the power of 3, again, which word do we think we're going to be using?
Cube.
Cube root, excellent. For the power of 4, which one are we going to be using? Fourth root, 4th degree root. Power of 5, we're going to be using
5th degree.
5th degree root. Okay, very good. Take another minute. I want to make sure that you guys have this definition. And then we'll again use it to elaborate on these examples. So powers, we're going to change them into corresponding roots. You guys good? All right, let's go on. So, if we know that 3 squared is 9, we said that the square root of 9 is 3. We know that 3 to the third power is 27. How would we reverse it to say in terms of a root? It's going to be what kind of a root?
Cubic.
Cube root of
27.
27 is 3. Very good. Let's do another one. This one. Just say it out loud as a class.
81.
Again, not talking about the cube root here, we're talking about the fourth.
Fourth.
Fourth root, 81, is 3. You guys getting the hang and seeing the pattern? Now, for this one, what's it going to be? Very good. The fifth root of 243 is 3. And the last one? Excellent. Again, this is the pattern we're looking for in these problems. Now, do you think we have to write out this entire expression? Square root of 9 is 3. Do we write math like that?
No.
No, we use symbols. Which symbol do we use for square root? A radical. So, looks something like this. Now, guess what? For other square root, for other roots, we're going to be using the same symbol, the radical. Only, in this case, it's going to have an additional notation. It's called an index. So now again, couple of words again. I want you to kind of understand the difference between these two words. The degree over root and an index. The degree over root is this number. Or again, here. Square root's got a degree of 2. Cube root's got a degree of 3. Very good. Now, the corresponding number that is in this notation is an index. It's put right here, in the upper left-hand corner of the radical. So a cube root is going to be written like this. This is going to be a 4th degree root. Now, do we use the 2 when we write out the square root? No, you haven't been using that. Guess what? Still stands. With square roots, we do not need to write out the index. Let's write out this expression. Okay, what we're looking for here, somebody say to me in English. We're looking for the fourth root of 16. Excellent. So we're looking for a number which equals 16 when raised to the 4th power. Can somebody think of such a number?
2.
Yeah.
4. Only 2.
2. This 2 is going to work. 2 to the 4th power is 16. Can somebody think of a different number? Tricky question, but I want you to start thinking. Was that? Very good. You got it. It's going to be a 2 or a negative 2. Why is that? Again, what happens when we raise negative 2 to the 4th power?
It becomes even.
It becomes positive. Now, do you think that's fine for defining this function of a 4th root, 4th degree root? Not really, because remember, the function's got to have what? A unique answer to each If we're taking the 4th root of 16, do you think it's going to be making more sense if we took the positive 2 or negative 2 as a kind of like the main answer?
2.
The positive 2, very good. So that is going to be our definition of principal root. Again, it is just the positive root. Positive number, and you're trying to take the even power root of that number. How many answers are you going to have? 2, positive and negative. If you take the odd degree root, it's going to be just 1, just so the pattern. Now, if the number is 0, how many possible answers could you ever have? Just 1, because again, 0 is the only answer that you're going to have when you take a root of 0 of any degree. Oops, not 0, but 1 and 1. Now, negative numbers, a little bit trickier. If we take the even degree root of a negative number, can we do that?
No.
No, why not? Because any number raised to an even power is going to be a positive number, right? Again, what's 2 squared?
4.
Negative 2 squared?
4.
4. Again, we cannot get a negative number there, so this is going to be 0. And again, if we're taking the root of odd degree, what's going to happen? We're going to have the, how many solutions?
1.
Just 1.